Hello everyone, welcome back to Bright Engineering. So we are continuing with changing from rectangular form to polar form. So we've already established how to go from rectangular or Cartesian form to polar form. So you first of all find your modulus, your argument, and then you set it into this equation, right, or this function. So the second one, which is the second example, we are going to get 2 plus 3i, and the first thing that we have to do is to find our modulus, which is our r. So it is root of 2 squared plus 3 squared, which is going to give us root of 4 plus 9, which is root of 13, right? And then now our argument, which is theta, is the tan inverse of the imaginary 3 over the real, which is 2. And this, when punched in the calculator, when you change your calculator to rad, when punched is going to give you 0.98. Now, just like we did with the first one, we have to compare with our diagram. So the imaginary parts and the real parts are all positive, so it means that it's going to be in this quadrant. And if it's going to be into this quadrant, if our x here is 2 and our y here is 3, then it means that it's going to look something like this. And always we link it with our x as is like this. And I said that always theta is the angle that is between, or that is made between, the hypotenuse and the positive x-axis. So this is theta. So when we found theta gave us 0.98. So it means that unlike the first one, we are not going to add or subtract anything from it, because theta has been made with the positive x-axis and is going to remain the same. So if you want to write the polar form of that, r cos theta plus I sin theta, we just have to insert it in. So we know that our r is root of 13 cos of 0.98 plus I sine 0.98. So the I here also is indicating that this part is the imaginary part of the complex number. All right, so Z2 is this. Thank you very much, and if this video has been helpful, please don't forget to subscribe, share, like, and comment.